Hello guys, welcome to Spark Tech Academy. Today we will be going through the competitive exam lectures. Now I have just started a batch of JEE AEE Executive Engineer for the MSCDCL, Transco, Discoms of all the national states. Now states as well as for any national ISRO or DRDO exam, it will be very helpful to you. Now we will be starting with measurements and instrumentation subject first of all. Now the basic of measurement is the units and the dimensions. Basically, what are the electrical quantities with the units already we have gone through in our diploma first year syllabus. Still I will be going through the dimension calculations of that units. So please concentrate on it. What basic first we will go through work. What is work? Work is nothing but, you can say, force into displacement. Force into displacement. Displacement. It is a very basic expression. From this we will be going to derive each and everything. Now what is force? Force, if you go through basic physics, it is nothing but mass into acceleration. Acceleration. Now what is the acceleration? Acceleration is a distance covered per unit time square. This time will be in seconds, because in a fraction of time you will going to achieve a kind of speed which is nothing but the acceleration. Now what is velocity? Velocity is nothing but a speed is equal to distance upon time. Very basic it is. Now why you will be saying that why I am going through such basic kind of things? Because from this you will be deriving the voltage, current expressions, power expressions, energy expressions, and even permeability. Now just go through it. I will write basic things here. First of all, what actually we will be doing is, m is nothing but mass, n is for length, a is for amperes current, you can say ampere current, and t is nothing but time in seconds. You will be writing this while doing the calculations, and k is nothing but a temperature constant. It is not used many times, but still as we are going through unit and dimensions, that's why I am stating it also. I am taking it in also consideration. Now what I will be doing is, for mass, for force we will first find out the equation. For force, mass is denoted by m, hence we will write here m, into acceleration. The acceleration formula already I have told you, distance upon time square. This distance will be, first of all I will write here as acceleration only, and then I will be writing here the acceleration unit and dimension formula. Now acceleration, just now I have told you, distance upon time square. Distance is nothing but, it will be in meters. That's why it is written by L. L is nothing but the length. Distance is nothing but the length which is being covered for a specific time period. And T, time, that's why I am writing it as T, and it will be T square. It is nothing but, when it comes into picture, this will be the formula when you adjust the numerators and denominators accordingly. This is the formula for acceleration. Now just I will substitute it in this mass into L T raised to minus 2. This is nothing but M L T raised to minus 2. This is the formula for force. Force will be in newtons. Newton per meter square. Newton per meter square. And it is nothing but meter per second square acceleration. Just now we have derived this the same way. We will be writing here the velocity means speed's formula. Speed is nothing but length divided by time. It is nothing but L into t raised to minus 1. And you know speed is in meter per second. You can say velocity is in meter per second. Now please note down it. It is very helpful to you in calculating the further calculations. The further equations will be derived from this only. So please go through it in very nutshell. I am given this as it is a very simple way to explain these things. No one will be going to explain you the units and dimensions in this way. Units and dimensions. Units and dimensions chapter now we are studying in measurement. So please go through it. Now with the help of this I will be deriving one by one. Now I will write the formula of voltage plus. First I will write for voltage. Voltage is nothing but when you give a kind of voltage to it, what circuit will do is it is nothing but some sort of work will be carried out and a charge will be flowing through it for any circuit. Now just now we have calculated work. Work it is nothing but force into displacement. As just now we have calculated the formula for force, please substitute that formula. That formula is nothing but mass into L into T raised to 2 into the displacement will be in L. That's why it will be M L raised to 2 T raised to minus 2. It is the work formula, work dimensions formula. So please note down it. It is very helpful to you in further calculations. Now what is charge? Charge is nothing but current I. You can say current I into time t. When the charge is accumulated on any body, when you are trying to suppress a kind of current through it, we are applying some kind of force to it, means voltage to it, and the current will flow through the circuit. And when current flows through the circuit for a specific time period, the charges will be accumulated across the body, and that charges are nothing but current into time. And that's why we are taking current as E. Already I have told you current is denoted by A and time is denoted by T. Hence the charge dimension formula will be A into T. Now substitute these both the quantities work and charge in this equation. You will get it as M L square T raised to minus 2 divided by A into T just calculate for the numerator and denominator. You will get it as t raised to minus 2 minus 3 it will be, and this will be the A. A is nothing but amperes in this case, and this is the formula for voltage. Are you getting this? This is very simplest formula, or the simplest way. In the way I am trying to derive these equations, the dimensions and units, and accordingly I am giving you what kind of things are being done while calculating the formula. It is a very simpler manner to get it done. Now we will be deriving, and again one thing I have to specify that current is nothing but I is equal to amperes, hence its dimension formula is nothing but only A. Take this into consideration. Now what we will be doing is, now we will be calculating the power. You know, power is nothing but V into I. This is a basic formula of power. Now what we will do is, we will just substitute the voltage m L square t raised to minus 3 into A for current. Now the formula of power will be A raised to 2. Just the laws of indices we are using here. The laws of indices, when t raised to minus 2 is multiplied by t raised to minus 1, or only the t, what we will be happening here, when denominator goes to numerator, what shiftings will be done, that accordingly I am calculating the things. Now while calculating charge, the one thing is missing here, minus 1. This will be minus 1 and this will get cancelled. This is the power equation. By mistake it was done, so I have corrected it. Please note it down. Now again one thing, energy. What is energy? Energy is nothing but power into time. Hence, just now we have calculated the formula for power. We will substitute it in energy, electrical energy. It will be mL t raised to minus 3 into t. It is nothing but mL2 t raised to minus 3 plus 1 is nothing but minus 2. Hence this is nothing but energy formula. It will be in watts. It will be in watt hour, or kWh you can say, or kilowatt hour, the energy. Please note it down. Just now I have calculated energy, power, voltage, current, each and everything, the basic parameters of electrical engineering. The base of electrical engineering goes through this electrical quantities. So please note down it very carefully, and how step by step I have derived these things. Please take this into consideration. Now we will be calculating capacitance and inductor. Capacitance and inductance. Now capacitance is nothing but charge Q per unit voltage applied. Hence, as you know, charge Q, just now I have derived it as A into T dimension. and voltage also we have derived. Please take that the same value of that voltage while calculating this. It is nothing but mL2 t raised to minus 3 and ampere, which will be taking into consideration, and accordingly just substitute the values here. The Q is nothing but A into T divided by M will be A square T raised to 4 L raised to minus 2 M raised to minus 1. Please note it down. This is the capacitance dimension formula. Capacitance will be in farads. The unit of capacitance is farad. Now, in the same way, we will be deriving inductance. What inductance is? First of all, while calculating inductance, we will first try to calculate the basic formula for flux, you can say, because inductance is nothing but phi by I. Now, what is flux? As in the same way, I have just told you the current and voltage relation. In the same way, what happens is flux. What flux will be? Flux will be nothing but voltage V into time. As in the same way, I have calculated the charge. What charge is? Charge is current into time. The same way, flux is voltage into time. This is also one formula, very basic formula. Please note it down. Flux will be in Weber. Flux will be in Weber. So, just now I have told you the formula for voltage. The voltage formula, just I am substituting it. E raised to minus 1 into T means it will give us M L T raised to minus 2 A raised to minus 1. It is nothing but the dimension formula for flux. Just I will substitute this, and I dimension formula is only A, hence I will just substitute the formula mL2 T raised to minus 2 A raised to minus 1 divided by A. Now the formula will look like Henry. The inductance ampere seconds. Ampere second is the unit for charge. So please note it down. It is very important. The inductance formula and capacitance formula. Now I will be going through electric field intensity. Electric field intensity, you can say. The electric field intensity is nothing but electric field intensity. It is nothing but charge, or you can say force which is been given and a charge is developed. Means when electric field intensity is generated when a kind of force is given, which force will try to develop a charges through the body and electric field will be created across it. So just now we have derived the force formula, force basic formula already we have gone through. It is nothing but mass into acceleration, and accordingly its formula will be mLt raised to minus 2. And charge, just now charge is nothing but A into T. So just resubstituting in this equation, you will get as m L A raised to minus 1 and T raised to minus 3. It is nothing but electric field intensity Newton per Coulomb. Charge unit is in Coulomb, force will be in Newton. Now what we will do is electric flux density, magnetic flux density B, magnetic flux density, it will be phi by A. Just now we have calculated flux. What is the flux formula? Please note down. M, L, T and A. T, I think it is, and as this is area is nothing but length or distance square, that's why it will be L square. Just resubstituting in this formula, you will get as m T raised to minus 2 A raised to minus 1. It is nothing but Weber per meter square, or you can say it as, or Tesla also, magnetic field density. Now again one thing will be H will be magnetic field intensity. What will be it? N into I divided by L. It is ampere turns divided by length, and accordingly we will calculate the formula for that. In this way, as this N will be neglected, N will be dimensionless, hence neglected, the turns will be dimensionless, N will be dimensionless. That's why the formula will be just, you can say, ampere divided by L. It is nothing but AL minus. It is the electric field intensity. Now from these two we will calculate the nu. What will be nu? Nu will be B divided by H. From this, just now we have calculated B, this is nothing but H. The formula will look like divided by A into L raised to minus 1. The formula will look like This is nothing but the derivation for nu. Nu is nothing but Henry per meter. Henry per meter, its unit. Nu is permeability. It is permeability. Permeability. Permeability in terms of magnetic field. We have derived this also. Henry per meter. Its unit will be ampere ton per meter. Ampere ton per meter. Magnetic field intensity. Please take it down. Thank you for watching eSpark Tech Academy by Saurabh Survasya. Please do like and subscribe the channel, as from today onwards I will be going through competitive exam lectures, and in that I will be just going through the basic concepts, the units and dimension formulas. It will be asked in exam. I have just now covered all the things which are asked in exam before also, and it will be asked in a random manner. Electric field intensity, magnetic field intensity, even I have also told you magnetic flux density, and even permeability is also been derived here. Voltage, current, power, energy, even inductance, capacitance, all the things have been derived. Even one thing which I have not told you is R is equal to V by I. Here, as you know, the basic formula for voltage just now we have derived. Just substitute that voltage in that, you will get the formula for this MLA, ampere. Just I am taking it down. Actually, what the things has been. Now in this way it will be m L square e raised to minus 2 and t raised to minus 3. It will be in ohm. You know the resistance. Same way you can also calculate the resistivity. Resistivity R is equal to rho L by A. In this way, when you calculate rho will be nothing but R into A into L. Now here A is area. I have already told you A is nothing but area, and it will be L square. Hence only substitute this thing, A into L square into L. No, this will be divided by L, hence it will be L, and here you will get L into R into L only. This is resistivity. Resistivity. Ohm meter. Ohm meter. Now, in same way as I have calculated resistivity, the dimension formula for resistivity will be nothing but R into L. Just substitute the value of above equation, minus 2 t raised to minus 3 into L. Now it is nothing but ml cube a minus 2 t raised to minus 3. It is just the resistivity formula. Just now I have derived in front of you the dimensions of resistivity. This is very important formula. This is also very important. This is nothing but the resistivity. In same way, if you want conductivity will be just reciprocal of resistivity 1 upon rho. You will get it as equation m raised to minus 1 l raised to minus 3 a raised to 2 and t raised to 3. It is nothing but conductivity formula. Please take it down very carefully. It is little bit messing up, but still if you watch my video in sections, you will understand each and everything, how I have calculated and how you are going to analyze the things and try to make the analogy for voltage, for current, for power, for time, for acceleration, for velocity, for speed, or even try to analyze the things in a simpler manner, in a stepwise manner. Then you will be definitely, you will find out it as a very easy concept which no one will be going to explain you in a basic manner of units and dimensions. So thank you for watching Spark Academy. Thank you.